put a piece of cloth in front of it.
X-ray vision used to be something only seen in comic books, but it may not be that way for long.
In its final form, what the device will do is it will make an image on a computer monitor that will be of whatever is in the field of view, much like a point-and-shoot camera.
University of Memphis student
Which scanned the image.
xryvinyt is working to use radio waves to create real-time imaging that could help both the military and Homeland Security.
What we're trying to do is form real-time images at sub-millimeter wave frequencies, or at sub-millimeter waves, otherwise known as terahertz frequencies. The detector on the other side will detect the energy.
Terahertz radiation is able to penetrate substances like clothing, similar to the way microwaves from cell phones do.
So I'm scanning the scene this way.
In this test, the radiation is focused on this moving rod by a series of mirrors.
As this moves up and down, its image moves left and right on the spectrum analyzer.
Orges, a PhD candidate in electrical engineering, is enhancing and improving research in this area from the 60s and 70s, and has found a way to make it easier, faster, and cheaper.
I was put in charge of finding out why it didn't work. And in the process of doing that, I came up with a much easier way of doing it.
Instead of using expensive lasers and semiconductors,
as the disc moves,
4G constructed a device that uses a spinning disc with holes drilled in it to measure the amount of energy making it through.
This mirror focuses the energy or the image onto this slit. And then the holes, as they go through, they will scan the image that's on the slit, and the receiver that's placed behind the holes will detect the energy.
It is the measurements of that energy that is used to make the image. And because terahertz frequencies can go through most common materials, the image is not blocked by clothing.
What you're seeing there on the screen is the line image of this rod. So the scene is being scanned this way. And so here you see nothing, here you see the rods, that's why you have more intensity there, and then you see nothing again. And if we put a piece of cloth in front of it, you still see the image over there. The detector on the other side.
Assistant Professor of Electrical and Computer Engineering, Dr. Eddie Jacobs, had worked on similar technology in the Army and decided to bring his work on real-time imaging devices with him to the U of M.
I asked xryvinyt, my graduate student, to take a look at this and do some analysis and see if we could apply this to this particular region of frequencies, the terahertz.
Even though no groundbreaking physics are involved, Jacob still sees the device as an important innovation in the engineering world.
We kind of assembled things that haven't been put together before. The engineering benefit of this is that it is low cost, easy to manufacture, and will provide an imaging capability.
When we expand this to a two-dimensional image,
this technology could have many practical applications, including helping helicopters to land safely.
This camera, so to say, will be able to see through the dust, so the pilot of the helicopter should be able to see where he is landing.
Detecting explosives.
Explosives, as it happens, reflect or absorb these colors differently than other materials, and so there's very distinct chemical or spectral signature at these particular frequencies that you can use to identify things such as C4.
And finding wires that would trigger roadside bombs on the battlefield.
This device would be able to see those wires. And also, you know, if there's something that's made out of metal, for example, on the road, it would be able to see it, and so the soldiers can stop and, you know, find out what it is, and so things wouldn't blow up.
By being able to effectively use real-time imaging, this technology being developed at the U of M will not only save people a lot of time in places like the airport, but it could also save lives. For the University of Memphis, I'm Simon Wright, Senior, Philosophy major.